Hello students, welcome to the new video. In this video, we are going to learn about the Venn diagrams. Okay, so let's read some theory about the Venn diagrams first. Okay, so Venn diagrams are a way of showing sets and relationships between sets. Okay, so Venn diagrams are basically there is a way of showing a set or a relationship between the two sets. Venn diagrams are introduced in 1880 by John Venn. In the Venn diagram, the universal set is shown by a rectangle. So this is a universal set. I told you in the previous video, this is a notation of a universal set. So the universal set is shown in terms of a rectangle, and other sets are drawn as a circle or oval within the rectangle. It can be a circle or it can be an oval, and it should be in the Venn diagram, right? The universal set is in a rectangle and the other sets in oval or a circular shape, right? So Venn diagrams basically show the two sets or a relationship between the two sets. Okay, the diagram here shows three typical Venn diagrams. Okay, these are the three Venn diagrams. Let me move down. Okay, these are the three typical Venn diagrams. Okay, so let's talk about the first Venn diagram. This Venn diagram shows two sets, the set P and the set Q, where there are some elements that are in both sets. So this Venn diagram shows the two sets P and Q and the universal set as well. And it shows that there are some elements which are in both of the set in common. Now let's talk about the second Venn diagram. So this Venn diagram shows the two sets P and Q where there are no elements that are in both sets. Means the set P and the set Q are totally disjoint. None of the element is common in both of them, right? So the set P and Q are disjoint sets. So the definition of here, we have learned about the definition of a disjoint set. So what are the disjoint sets? When none of the element is common in the two sets. When no element is common, when there is no element that are in both sets, that is a disjoint set. Let's move to the third Venn diagram. This Venn diagram shows two sets P and Q where all the elements of set Q are also in set P. This Venn diagram shows all element of Q is also in the set P, but you can see all the elements of Q are inside of P, but P also contains some other elements which are not present in Q, right? So we can say the set Q is a subset of set P. Here Q is a subset of P, not P is not a subset of Q. Why? Because Q is inside the P, but P contains some elements which are not in Q, right? So only Q is a subset of P. Okay, Venn diagrams are not restricted by two sets. Yeah, we have learned about there can be three as well. They can have three or more sets. Yes, sometimes Venn diagram need to be drawn and the elements of the sets filled in. Yeah. Let's do an example on the Venn diagram. So let's say the universal set is integers from 1 to 20. P is a factor, set P is a factor of 12. So what are the factors of 12? Let me list this. This is given in terms of a rule. So we have to list the elements. Factors of 12 is 1, 2, 3, 4, 6, and 12 itself, right? Now the set Q is a prime numbers. Between 1 to 20, you have to list the factors of 12. Okay, and we have to list the prime numbers between 1 to 20. Now you can understand the concept of a universal set. If you do not know what are the universal set, go check out my video which I have explained what are the universal sets. Now in this question you can easily understand why we define the universal sets, why they are universal sets in mathematics. Thus now with the help of this universal set, because prime numbers are infinite, there are so many prime numbers that is not a finite set, but this universal set make this set Q finite. Okay, so in set Q we have to list the prime numbers between 1 to 20. So the first prime number is 2, 3, 5, 7, 11, and we have 2, 3, 5, 7, 11, 13 is a prime number, 14, 15, 16, not 17 is a prime number, and 19, 20 is not a prime number. So these are the prime numbers between the integers 1 to 20. Okay, now for part A, the question says draw a Venn diagram to show the elements of a universal set and its subsets P and Q. Okay, so let's draw the Venn diagram. So draw a rectangle which shows the universal set, draw a set P and draw a set Q. Right. Now list the elements that are in both the set P and set Q. Okay, now we have to list the elements of set P and the set Q. You can see there is an intersection. The set P and set Q has a common element. What elements are common? You can see 2 and 3. These are the common elements in both sets, right? So we can put these two elements as a common, and the rest of the set P elements are 1, 4, 6 and 12. So 1, 4, 6 and 12. 2 and 3 are done. The rest are 5, 7, 11, 13 and 17 and 19. Okay, now these are the elements which are in set P and set Q and in the intersection as well. Now we have to list the rest of the elements which are not in both, not in P, not in Q. Those are outside. Okay, so it is 1, 2, 3, 4. We have 5 as well. We have 6. We have 7. We don't have 8 in both of them. We don't have 9. We don't have 10. We have 11. We have 12. We have 13. But we don't have 14, 15, and 16. But we have 17. We don't have 9, 18. We have 19 and the 20 as well. Okay, now for part B, it says list the elements that are in both set. So which two elements are in both set? The element 2 and the element 3. So these two elements are in the both sets, right? There is an important note when we are drawing the Venn diagram and filling the universal sets and the two sets. So do not forget to fill in the elements of a universal set that are in neither P nor Q. So that is the important note, because most of the students forget about this, because they just draw the rectangle, the set P, the set Q, their intersection, and just list those elements, and they totally forgot the elements at the bottom which is written over there. So do not forget to fill the rest of the elements of the universal set that are not present in both sets. Okay, now let's move it further. We do not put the elements in a Venn diagram more than once. All right, this is an important point, that we do not put an element in a Venn diagram more than once. We can put it just one time. Okay, so for example, if A is a set, letters in the word LABEL, the set is 1 ABE. Sorry, it's not 1, it's L. It's a printing error. Okay, so this is the example that if you have a set A and it has a letter label and it contains the word LABEL, there are two L's, A, B, and E. So how can we write down the set? We can write down the set is L, A, B, and E. And you put those 5 letters in the Venn diagram. You would not put the letter L in twice. So this is the important point. So most of the students get confused that if you have 2 letters in a number or in a word, or 3 letters, we can write it down twice or thrice. No, we can just write down no more than once. Just once you have to write down that letter in the Venn diagram, not more than one time. Okay, so here is a exercise, the practice questions for you guys. Exercise 2.2, draw the Venn diagram to show the elements of the universal set and its subsets PQ. So I want you to practice these 6 questions, and you can please take a printout of these questions and do practice. And if you get stuck in any question or you have any, you do not understand anything, so you can just simply comment in a comment section, and you can take help from me. So I hope this is clear. What are the Venn diagrams and the relation between the two sets? So see you, do practice the questions. See you in the next video with a new topic. Thank you. Take care. Bye-bye.